We now move on to our next keynote session on another important topic of high performance and adaptive computing leadership. To share his thoughts on the topic, we have with us Manik Kapoor, Enterprise Sales Leader, Telecom, AMD. Manik leads the Telecom Center of Excellence at AMD for India and APJ, a professional with close to 20 years of experience in technology in both the hardware and services. With expertise in product management and hands-on experience in exploring and developing new markets, Manik comes in with a rich knowledge on what drives enterprises in the telecom sector and help them in developing and adopting to the latest technology. Now AMD's hypergrowth in this key sector. Over to you, Manik.
Hi, and good morning, everyone. My name is Manik Kapoor, and I lead the Telco CUE for AMD for India and Asia Pacific Japan region. Today, what we're going to talk about is the high performance and adaptive computer leadership that we bring into the market, to the industry, with the strongest portfolio from the data center to the edge. First of all, I just wanted to, for the people who are not really aware of what AMD brings to the market, the products, I just want to take everyone through the offerings, the product line, the portfolio that AMD brings into the market. So with the leadership desktops, ultra-thin and gaming notebook processors, AMD are the only company to offer up to 16 cores on a mainstream desktop solution. When AMD Ryzen hit the market back in 2017, the DIY DT desktop market was locked into 10 years of quad-core. AMD brought the competition into the space, and now the consumer has a choice to select up to 16 cores solution in a non-HDD space. Similarly, from top to bottom, graphic cards and the game consoles based on the RDNA architecture, our latest release on RDNA 2 architecture, can be found in the next generation of performance gaming consoles inside the PlayStation 5, Xbox Series X, and this is actually the second generation, consecutive generation for Sony, and the third for Microsoft, choosing AMD graphics in the heart of the consoles. Our 7nm RX 5000 series gaming CPUs and GPUs have the price to performance leadership in the mainstream gaming segment. We can even find AMD Radeon powering the cloud gaming with Google Stadia, AWS instance, and much more. AMD EPYC and AMD Ryzen Instinct are leading the exascale era today. The fully programmable heterogeneous compute platforms are class-leading EPYC server CPUs with up to 64 cores can be found in the data centers of multinational companies like Google, Twitter, Azure, IBM, Oracle, Amazon Web Services, Tencent, Alibaba, Dropbox, and the list goes on and on. With the recent acquisition of Xilinx, the FPGAs and adaptive SoCs such as SmartNICs, high performance, low latency Ethernet cards for systems optimization are also part of the scalable processor integration family today. Okay, so with the latest on the EPYC, which is the data center portfolio, the industry leading product and feature sets that offer are the best performance, the high performance options that can be used everywhere in the modern data centers and modern workloads today. Be it the cloud, be it 5G on the telecom side, be it the AI and analytics, be it on AI and analytics with the training, inference, any of those workloads, and much more to go for. With 2017, when we re-entered the data center market, AMD changed the CPU market space with the launch of EPYC 7001 series, which is the Zen 1 architecture for using the Zen core chiplet architecture on a 14 nanometer die. So with the system on the chip architecture, AMD was able to integrate a separate security processor and begin implementing our advanced on-die integrated security features like secure memory encryption, secure encrypted virtualization, as well as enabling the generation over generation architecture innovation and engineering advances AMD is known for delivering. The architecture advantage delivered by first generation EPYC set the stage for the second generation EPYC to really accelerate the server performance. With the launch of EPIC 7003, which is the Zen 3 architecture Milan code name, we are increasingly, increasing our already impressive industry leadership, counting our quest to help provide better data security. We have added SEVs, which is the nested paging, secure nested paging, increasing the protection and the security of virtual machine data. With the implementation of additional design and features, we have been able to improve our already outstanding performance leadership by an average of 15% in Milan, and in some cases much more than that. An important aspect of 5G is the architecture change and also the shift of where the silicon is being deployed to scale forwarding. The control plane and the user plane are separated to allow the user plane to scale separately. The planes could be custom to ASIC silicon, a container, a virtual machine, on an x86 or a bare metal appliance. What ISPs are finding is with a large quantity of the high performance cores and ability to establish packet forwarding through each SoC, each core on their SoC, can be effectively parallelized. Right. So 5G user plane and the CDN take the advantages of the huge 128 PCI Gen 4 lanes and the DPDK support in the third generation of EPIC. 5G actually is the software scales with the cores, and so the core count does matter. 64 cores on AMD top OPN versus 44 per socket on Intel. Everyone knows the answer. EPIC provides more I/O, over 2x more I/O. With 128 PCI Generation 4 lanes, the 5G will drive 100 times or 10 times at least the traffic of 4G, so this is critical and important to have a fast I/O interface so that your network doesn't becomes a bottleneck. So encryption also is a very key feature for all the 5G software implementations. Encryption is not bolted on. So our friends in the market use a secured enclave technology, which requires awareness of the application software. However, with AMD, it's a software agnostic. It's a separate hardware on which the encryption sits on. So you can have a secured encryption virtualization. Each VM that you create can be encrypted separately, using the hardware, irrespective of the software underlying. So market leading 7 nanometer silicon provides greater efficiency per watt, which is the most critical part for the 5G era, because with more and more traffic getting generated, it's obvious that we need to have more and more compute to the core or to the edge. With the given power, capping at the edge, especially at the edge, we need to ensure with the given power, we need to process that data more efficiently at the edge itself. And hence, more number of cores, I/O does matter. And with 7 nanometer, compared to today, our friends for 10 nanometer, 7 nanometer gives at least 1.6x logical density, which is 20% speed improvement and 40% power reduction. So it becomes an aggregated choice for all the operators, all the software vendors to choose, the greener options available in the industry today. We at AMD also understand the complete 5G era. The disintegration of the software, the hardware with the network virtualization, the shift to cloud native or DevOps. Most 5G software scales with cores, as I said. So it becomes more important for you to have more number of cores, or more cores on the same socket to process more data, on the chip. The adoption of hybrid clouds, is another. Adoption of hybrid cloud is another native encryption of the memory and virtualization that helps 5G slicing. The urgent need of richer margin services, network-based insight, MLDL, SaaS, security. What to also understand is the video with new experiences. With the new experiences, video data will represent 90% of all internet traffic by 2028. The telcos are trying to manage their ever-increasing expectation of the consumers and the business while currently seeing a very little incremental average revenue per user, despite picking up the cost of the upgradation of the infrastructure. telco CTOs view video and gaming as critical to their success, as it is the point of control where they can provide a differentiated user experience while the network allowing them to secure customers' loyalty. Technically, 5G is the first opportunity to deliver the fully impressive technology such as VR gaming due to the enhanced latency and the radio throughput characteristics. The richer experience services like telcos are seeking for more contextual and insightful usage of the network source data to move into deeper, richer margin business as their traditional packet core transport business becomes a commodity. Telcos view the new wave of the industry changes such as smart cities, retail, e-health, automated industry 4.0, e-agriculture as a rich new areas for business engagement as they then need public radio coverage models and the unique network characteristics best served by the large network providers. Our software partners across all telco domains from 5G core through OSS, BSS, RAN, and many others are demonstrating predictable scaling of extra code on the third generation epic processors. So the modern SoC chiplet architecture is optimized for low cache latency and cloud native microservices and the containerized workload. So 5G software scales with the cores, and cores count does matter. 64 cores for AMD top 10, is the choice to go forward for the 5G. We are making great traction among the various enterprise verticals due to the strength of our product and future roadmap. There is no reason why we should be built together. The VM density, the raw compute throughput of 2P platform, and the compute efficiency of our 1P platforms are all benefits that are turning enterprise customers on AMD. So leadership in the workload that run the enterprise, superior virtualization performance in the cost, record virtualization performance up to 50% lower TCO versus competition, 82% Java-based application performance benefit, 2x performance on Microsoft SQL Server, 76% faster SAP SD benchmark performance, record-breaking server efficiency, energy efficiency. And that's not only on the enterprise, the cloud, which is driving performance in the TCO across the world's most dense cloud network, developed customized EPIC CPUs for the most important cloud workloads, which delivers 1.6x more virtual machines in the same rack capacity or the same power capacity. It enhanced the Docker performance by 83%. More memory footprint, more memory bandwidth by about 45% helps the cloud service providers to expand and to offer high memory instances to their customers at the right economics. For cloud sizing, many IT decision makers look at the venerable spec 2017 integer or spec throughput matrix. I know the T size does for the compute does not fit for all, but for both second generation and the third generation, EPIC outperforms the latest competition from Intel with their top performing dual socket Xeon Platinum 8368Q by at least 50%. So cloud providers are taking advantages of that additional performance to significantly increase their compute density and provide more performance per socket per rack than previously available. Across the core count option, this third generation EPIC series outperforms the latest Intel competition and still have more options for dense cloud compute needs. The third generation Intel Ice Lake tops out at 40 cores and is comparable to a performance of 32-core EPIC 75F3 at 40% less CPU cost. Okay. So that's the power of the EPIC processor in the data center. With 64 physical cores in a single socket, 128 PCI Gen 4 lanes, 8 memory channels per socket, and up to which can scale up to 4 terabytes of memory per socket. That's a real powerhouse in the system. And that's not only the system that we're talking about. What we're trying to change here is how the landscape of the IT or data center has evolved over the years. We are also bringing these single socket disruptions in the market with the same core count, with the same feature sets available in a single core or a single socket configurations. So the L3, we at AMD supports the most or maximum L3 that can be supported on the Indian district level, support up to 256 MB of L3 cache, right? And the benefits of large L3 is the direct accessible per core. So the one thing of this, the chiplet design has helped us to bring L3 closer to the core. So rather than keeping a pool, it is now more closer to the core. So 32 MB L3 cache can be allocated to a single active core. So reduction in effective memory latency, application performance improves where data sets fits more naturally in the larger cache, better performance for large virtual machines. We also support synchronous clock speeds, which helps reduce latency, which helps improve memory performance, peak stream triad benefits, and bandwidth can improve by about 3 to 5% over EPIC 2 to EPIC 3. So critical for all workloads that are memory bandwidth sensitive like HPC. So I just want to leave this slide with the three key takeaways that I want you guys to remember. So the current generation 2 competes well with the third generation EPIC, with the third generation Intel Xeon scalable series. Even the most recent 32 core model is performing within 5% range of EPIC 7532, which is the second generation, at a 40% lower CPU list price. But now with third generation EPIC, there are several models in 34 core, 32 core space that competes on a per core performance. As I said, 75F3 is the high performance queues, which can be compared here. So the new 28 core EPIC Milan, which is generation 3 option 7453, has similar performance compared to a 28 core second generation Xeon Gold 6258R. And the 24 core third generation EPIC third generation Xeon Gold 6342, but delivering a much better value with an up to 2x performance or per system dollar advantage. Over the low end core counts, EPIC Rome will continue with 7252, 7262, and 12 core options in the terrific value starting at $348 price point. The 16 core EPIC model is still one of the best values in the market with 30% price performance advantage over 20 core for EPIC generation for Intel Generation 3 Xeon Silver CPUs. And as we're speaking on the performance, when we launched the second generation EPIC, AMD EPIC processor, we were proudly to show over 80 world records across a wide range of applications and workloads. And now the best just gets getting better. And that's a testament to the performance that the third generation EPIC family brings, the performance that delivers real work results for our customers. An example of how AMD helps reduce the total cost of ownership, whether it's time to consider refreshing, refreshing servers, where early adoption of EPIC solutions or planning a new deployment. The third generation EPIC 7003 series can have TCO benefits by deploying fewer servers to meet the same performance threshold of the existing or the current shipping servers. This is shown as a comparing 10K units of spec integer performance on Intel 8380 base servers versus EPIC 7763, the top end to top end. I would like you to note that we have multiple tools on AMD that helps you to calculate potential benefits, including the EPIC processor selector tools, which are available on AMD.com, server virtualization TCO estimation tools, bare metal and the greenhouse gas estimation TCO estimation tools, the AMD Cloud Cost Advisor tools can all help you to compute, your advantages in your infrastructure, in your environment. So at the end, I would just want to, say thank you. And with EPIC Instinct, we have the right portfolio. We have the complete portfolio that sits from data center to the edge, that suits from data center to the edge. Thank you so much for your attention.